Okay, so this is the second part of the video. Same concepts. We are going to transform different numbers into different powers with a base that we desire. So here I can see I have 3 to the power of x minus 8, so a little bit unfamiliar from what we're used to, equals 81. What my first priority is I need to make sure my bases match. So I don't really care to be intimidated by the x minus 8, okay? I just want to make sure that I make sure my bases match. So how do I write 81 with a base of 3? So here I'm going to get that this actually is, I'm going to leave this one as 3 to the power of x minus 8. And then instead of 81, I'm actually going to write it as 3 to the power of 4. Okay? Now, if these are equal, 3 to the power of something, right, x minus 8, if it's equal to 3 to the power of 4, that means that x minus 8 must equal 4. So what is x? Now, these are simpler numbers, so I could probably figure it out without doing the math by hand here, but I still do need to show it. So I'm basically saying x minus 8 has to equal 4 if these are equal. So what does x actually equal? Well, I bring my minus 8 to the other side as addition, and I get that x actually equals 12. Okay? So by solve, I'm solving for x. That's what solve means here. Okay? Now here, again, my priority is to say, okay, my base is 4. How do I make sure that this side has a base of 4? So I have 4 to the power of 2x plus 6, and that equals, well, I know 1 over 16 is the same as writing 1 over 4 squared. Okay, but I want it up here. Now, if I bring it up here so that it's on the same level, I'm going to end up with 4 to the power of 2x plus 6 equals 4 to the negative 2. Now, if 4 to the power of 2x plus 6 is equal to 4 to the power of negative 2, that means this must equal negative 2. So I'm going to say, okay, 2x plus 6 has to equal negative 2. And then I solve for x, and I get negative 2 minus 6 on this side. 2x equals negative 8. I divide both sides by 2, and I'm going to find that x equals negative 4. Okay, kind of squished over there. And I'm going to get that x equals negative 4. Now here, I'm going to do the same thing, but different numbers, different base that I'm working with. I'm working with a base of 2 this time. And I'm going to go, okay, my base here is 2 to the power of 5x minus 3, and that's going to equal, okay, how do I write 256 with a base of 2? So instead of 256, I'm going to rewrite it as 2 to the power of 8, and that is being raised to the power of x plus 2. Okay, so don't let that confuse you. Okay, now I have a power to a power. So I need to simplify this. So I have 2 to the power of 5x minus 3 equals 2 to the power of 8 times x plus 2. So I now need to distribute this. Imagine it like this. Imagine it was written like this. 8 to the times x plus 2. And that's distributive property. So this is actually equal to 2 to the power of 5x minus 3 equals 2 to the power of 8x plus 2, which means 5x minus 3 is equal to 8x plus 2. So I'm going to do that. I'm going to go 5x minus 3 is equal to 8x plus 2. And then I collect like terms. I'm going to get negative 3x here equals 19, because when I bring the 8x over, it's going to be 5x minus 8x, which will give me negative 3x. And then I have 2. Oh, sorry. That's where I messed up. 8 times 2 is not 2. This is 16. This here is 16. Okay. So here, my negative 3 is going to come over as a positive, and I'm going to get 16 plus 3, which will give me my 19. And then I divide both sides by -3, -3, and I get that x equals, because those cancel out, x equals -19 over 3. Okay? So that's what solve for x means. Now for D, same thing. But this time, they don't give away my base. Here we gave away, okay, base 3, base 4, base 2 was my goal. Here they kind of don't give it away. I need to find a common base that I can use to write both 64 and 16. Well, I know I can write them both in terms of a power of 4. 64 is the same as 4 to the power of 3, and that's being raised to the power of 2x plus 10. Okay, and 16 can be written as 4 squared. So I have 4 squared, and that's being raised to the power of x minus 3. So now I have powers to powers. So I have 4 to the power of 3 times 2x plus 10, and that equals 4 to the power of 2 times x minus 3. Okay, so when I simplify that, I get 4 to the power of 6x plus 30 equals 4 to the power of 2x minus 6. Which means 6x plus 30 has to equal 2x minus 6. So I get 6x plus 30 equals 2x minus 6. And I collect like terms. This one's going to come over. I'm going to get 6x minus 2x will give me 4x. And then the 30 is going to go over here as a negative. So I'm going to get negative 36. I divide both sides by 4. And I'm going to get that x equals negative 9. Okay? And then last question, I have 10 to the power of x squared minus 1. So this one looks even more different. Equals 1,000 to the power of x minus 1. Well, I know that 1,000 can be written as base 10, so that's the base I am choosing to go with. So I have 10 to the power of x squared minus 1, and that equals, instead of 1,000, I'm going to write that as 10 to the power of 3, and that's being raised to the power of x minus 1. So now I have a power to a power here again, so I have to simplify that, and I'm left with 10 to the power of 3 times x minus 1. Okay, so I have simplify that again, and I'm left with this equals 10 to the power of 3x minus 3. Which means x squared minus 1 has to equal 3x minus 3. And I have x squared minus 1 equals 3x minus 3. And now I'm going to end up with a trinomial. I'm going to bring everything to one side because this time I have an x squared, so I have a quadratic, and I'm going to end up with x squared minus 3x plus 2 equals 0. And from here, I have to factor. I need two numbers that multiply to 2, multiply to positive 2, but add to negative 3. And my two numbers are negative 1 and negative 2. So then I can put them in brackets and I can say perfect, x minus 1, x minus 2 equals 0. And therefore, since brackets lie, x equals 1 and x equals 2. Okay? So that is the entire lesson. That is writing exponents in different bases and solving exponential equations. Okay, so your homework is on the board. I'm doing my homework check tomorrow, so make sure you have everything done. Okay, I hope everyone has a great rest of your day, and I will see you tomorrow.